Hello everyone, welcome back to the channel. I hope you guys are doing amazing. So let's see today's daily challenge on Leetcode and try to solve it together. So I will show you multiple methods to solve this problem today. So let's just see the approach. Uh, you need to count submatrices with all ones. So yesterday we were given the question of how to count the squares of all ones that you can solve easily using a dynamic programming problem. Okay, so but this is a little bit difficult one, and in order to solve this in optimal time it is more difficult. So let's try to go step by step and understand how to approach exactly. And given this m cross n binary matrix, return the number of submatrices that have all ones. Okay, so you need to find the submatrices which have all ones in it. So now what you can see is that I will first tell you a pattern. Okay, I will first tell you a pattern and observation which you need in this problem at first. Okay, so let's say you are having a very large matrix. So if you remember yesterday's problem, what we did, we tried to find like in I comma j, in a square of I comma j, we tried to find the number of, I mean the number of squares which are ending at this point I comma j. Okay, so I will do a similar thing. I will solve I will go through each and every cell. Okay, if you have a large matrix, I will go through each and every cell, and at I comma j I will ask that number of rectangles with their bottom right corner as I comma j, bottom right corner as I comma j. Okay, so I hope you understand what I'm trying to say. And number of rectangles with their bottom right corner, and that rectangles must have all ones. Okay, rectangle of all ones, that goes without saying because that is definitely the problem statement. So what do I do? Let's see, let's say you have someone like this. You have a large matrix and I'm drawing only a small part of it where there are a few cluster of ones. Okay, so in order to give a better understanding, so you see, if you draw something like this, and let's say these all elements are zero and they are surrounded by some zeros, but this is the chunk of ones which you get in some large matrix. Okay, this is the chunk of one. What do you think at this point? Let this point be I comma j. Ending at this point, how many rectangles can you form? Okay, so if you try to visualize it very clearly, how many rectangles can you form? Ending at this I comma j. Okay, I will only talk of rectangles with ending at I comma j, and then I will travel through all possible I from 0 to n definitely. Okay, and let's say j from 0 to m or whatever be the dimensions. I will just traverse through all possible I and j and then add into my answer. Okay, whichever all the elements which are ending at I comma j. So now my focus is only on the rectangles which are ending at I comma j. Okay, ending in the sense that bottom right corner. So this rectangle is having a bottom right corner at I comma j. This rectangle also, you see this rectangle also, you see this rectangle also, so you get four rectangles here. Okay, and you see this also, you get this also, this whole rectangle. Okay, so I hope you are understanding where I am going, right? This whole rectangle also, uh, this whole rectangle also, this whole rectangle also. Okay, this whole rectangle also, this whole rectangle also, this is also there, and this is also there. These are all the rectangles which are ending at this I comma j. And if you see, the number of such rectangles will be nothing but the number of ones in this cluster. You see, one rectangle, two rectangle, this is the third one, this is the fourth one. Okay, there are four ones also. You see, this is the fifth, this is the sixth one, this is the seventh one. Okay, okay, so we have counted seven so far. Okay, now this is the eighth one, this is the ninth one, this is the 10th, 11th, and the 12th one. So you see, also you count how many ones are there. 1 2 3 4 5 6 7 8 9 10 11 12. So there are 12 ones. Okay, and the area of this whole thing, the area of this whole thing, area of this cluster of ones will give you the number of rectangle, gives you number of rectangle. Okay, so you try to just visualize it in this way, which are ending at I comma j definitely. But you see, can you draw some exceptions? Can you draw some exception? Is what the statement which I told, is this already true? Is this always true? You try to draw some other rectangle which looks something like this. Let me draw it first. So let's say this has 2, this has something like this, and let's say this has 4 and this has only 2. Okay, so let's say this has 3 and this is 5. Okay, so I hope you do get that this is a part of a big matrix, and this is the cluster of ones now which I got. This is the cluster of ones which I'm getting, and now I want to say that how many rectangles are there which are ending at this point I comma j. Okay, so I am asking you the same question. Now will the counting the number of ones be sufficient? You see, you will get this rectangle, this one. Okay, 3 you got, 4, 5, 6 you got, 7, 8, 9, 10 and 11. So you see, even this rectangle and this rectangle is possible. Okay, ending at this I comma j, you get many such. But can you tell that this is a rectangle ending at I comma j? If you want to include this one, you cannot. Okay, because this is 0 here, it's not 1. I mean, this is 0. I mean, it's not contiguous sequence of 1, or otherwise I have drawn a 1 here also. Okay, so and now if you try to see this rectangle, this is also not a part, this is also not a part. Okay, so you see, another observation which will be our observation number 2 is that you if I mean if you are in the current I comma j cell, and you see the height of this thing, height of this I comma j thing is lesser than some other rectangle, then definitely you need to chop off these two. Okay, you need to chop off this upper two. Okay, you need to chop off them. But so I hope you understand what is the second observation, right? Because these, they do not contribute to your area. Now this whole area of ones will give you the number of rectangles ending at this I comma j, and you can add that to your answer. But there is another discrete observation. This is very similar to the previous one only. If you have something like this, if your initial one is huge, but you get something like this. Okay, you get something like this, you get a cluster of one which looks something like this. You see, all of the towers now, all of these towers, I'm talking of again ending at I comma j, right? Now all of these towers, you look at all of these towers are less than the tower height which is at point I comma j, right? But you see, you cannot tell that this is your rectangle. Okay, because there is a vacant place here. So what you need to see, what you, another observation you get is that this cluster of ones should be from left. If you talk from right to left, if you are talking from right to left, okay, so if you are talking from right to left, the cluster of ones should be non-increasing in nature. The cluster of ones should be non-increasing in nature. Okay, this is the most important observation, and it is very important to understand, otherwise it will be a very big blunder. Okay, so I hope you understand this. So what we need to chop off this one, we cannot include this one in our place here. Okay, we will not be able to include this one, so our area will consist only of this. Okay, only of this. So the cluster of ones should be non-increasing in nature. So as you are standing on this I comma j, you see, you should take the height of towers, continuous height of towers of ones, which are non-increasing. It means that it is decreasing or remaining equal. Okay, this 2 and 2, it means that it's remaining equal. But you see, what is the height here? It's the height is 4, the height is 3, the height is 2, the height is 3. Okay, so you see, it decreases, but it increases. Okay, but from this 2 to 3, from you, as you are traversing from left to right, the cluster of ones is increasing, but it should be non-increasing. So you chop this value up to 2. Okay, so I hope you do get some idea, of how to solve this problem. So I will tell you this, I will just take this problem and just solve it. 101 110 110. Okay, so for as of now I think you have got some intuition. The intuition is completely clear to you. All of the methods are based on this single intuition, and you should definitely try on your own. Okay, so try on your own and pause the video now. Okay, it is, I mean, if you just are able to solve this from here, even in O of n cube time complexity, then it is also fine in this problem. Okay, it will be accepted, and just tell me in the comments if you are able to solve this from this position. If you are not, then definitely continue watching the video. But you should definitely try, okay, because you got the main intuition. If you understand till this portion of the video, you already got the main intuition. So I will solve this test case and tell you. Okay, so at first what I will do, I will construct a height of towers. Okay, so at every row I will tell that myself that what is the height of my tower at every row. Okay, so I will the height will look something like this. I hope you understand it right now. Okay, this will be 3, this is 2, this is 0. Okay, so as you are standing at this position, the height is 1. Okay, as you are standing at this position, the height is 0 because the current element is only 0. Standing at this, the height is 1, is 101. As you are standing at this position now, your height is 2. You can see your height is 2, so you get a write a 2 here. You as you are standing at this position, your height is 1, so you write a 1 here. As you are standing at this position, your height you see is 3. Height of ones is 3, so you write a 3 here, and in that way only. So instead of building a whole matrix, you can build a single height array which will get updated every time. You just initialize every element by 0, and whenever you get a 1, you just increment your 1, so automatically you get a 1 1 here, and you will get a 2 1 0 here, and whenever you get a 0, you just rub this one and initialize it to 0. So I hope you understand what I am trying to do it now. Okay, so you can do it in any way you like, just follow the same thing. And what do you need to add after you get this height array? After you have already got this height, what do you need to do? You see, uh, you simply adding the elements will not make sense, because the number of rectangles ending at this point is 1. This is 1, this is 2, but this again, this 2, it is not 3. You cannot just keep adding this, right? So if you are thinking that I will just keep a cumulative sum, I will just add 2 plus 1 and that will be the number of rectangles, but not. Okay, because this is one rectangle and this is another only rectangle. Okay, so what do you need to know is that from, as I told you in the intuition also, from left to right, as you go from right to left, as you are going from right to left, you can keep a variable min so far. Okay, so uh, you can keep a variable. So as you are traversing from left to right, you are keep an h variable height, which will be minimum so far. What does this mean? So I am starting from this point, right? I am iterating, and I will go to the left and I will keep the minimum so far. What is the minimum so far at this point? When you are at this height, it's 4. It's 3 now, it's 2 now. Now you get a 3, but your minimum so far is still 2. Okay, so you will get you will just update this 2. Okay, so you now you, for every element, you just move to the left and keep a minimum so far element. Okay, you just keep a minimum so far element and just update it. So I will just tell you quickly. Int n is equals to matrix dot size. I will just solve this quickly. Okay, uh, so m and n is the thing, so I will just put m and n instead of n. Okay, so you got matrix of 0 dot size also. And what are all the things now? You have a heights array definitely. Okay, so you do have a height. So as the height is n length, okay, it's of the second dimension, so I will just iterate through the loop once for m, okay, and another time for n. So I hope you do understand it now. And what I will do is that if I will see that if matrix of ij has some 1, then I will definitely update this height of j. Okay, I will do just height of j plus plus. Otherwise what I can do is that else I will just set this height of j to 0. Okay, so I hope you understand this. I am dynamically calculating this as I am traversing downwards. I am just simply calculating this. I am keeping this height with me. Okay, so what will I do now? I need to have some sum, okay, and I need to have a h, which is the minimum height so far. This h, as I'm starting from the current position, my current height is nothing but height of j. I will keep that as my thing, okay. And you see, I am, as I told you already here, I will iterate to my left and keep the minimum element so far. This h is my minimum element so far. Okay, so I will have another loop k, okay, which will start from j, and it will go all the way to 0 and k minus minus. It will first update this minimum variable, minimum so far variable, okay, of height of j, let's say. And you just add the all, every time you just add everything to your answer. Okay, so and answer you just add sum. Okay, so you also keep an answer variable at the, okay, so you just add this to your sum. So what is sum? You easily understand that, I think. Okay, so you just go to all the left and accumulate all of those answers which are possible. So sum is nothing but this thing. Okay, so what, how many ones are there in this whole thing? 4 plus 3 plus 2 plus 2. Okay, so this is what you got. This is 7, 8, 9, 10, 11. So you are getting 11 such ones. So this is nothing but your sum, and your whole answer is nothing but the sum of all the elements which are ending at I comma j. So sum is the variable which stores, okay, sum stores for store answer for ij. Okay, so in the answer you just add all answers for all ij's. Okay, add to answer for all ij. So you just simply add your sum and you just return answer. I guess it will just give fine. It will just give you a fine answer. So it is giving me a wrong answer, in fact. So let's try to see what is the error in this approach. So you see, instead of this j, this should have been k, because k is the iterating variable in this loop. So if I try to run now, will it work? You see, we get the accepted thing. If you try to submit it and check, okay, so you still get the accepted thing. And even in this time complexity, you see your runtime is really great. So I don't know how that's happening, but yeah, that is great. This is not a bad approach, you can say, but there is even a better approach. But for that approach, uh, I cannot explain you in detail because it will take a lot of time, but I will tell you the approach and I will also show you the coding. I will try to show you the coding also. So what do I need to do is that you need to learn about monotonic stacks. Okay, this is a separate kind of data structure, and definitely it's not possible to explain everything in one video. First you learn about monotonic stacks. The thing is that even if you want to optimize this approach also, first you learn about monotonic stack, then you solve this problem, this largest rectangle in histogram problem. Okay, so you solve this Leetcode 84. Okay, so you just solve uh, this Leetcode 84. This is a hard problem, in fact, but if you know this concept, this will be easy for you. And after you have solved this, 84 is in fact a sub problem of this. Okay, after you have solved this, then only you can go with this problem. Okay, then only you can go with this problem. So I will just suggest you can maybe stop here. Okay, if you don't know monotonic stack already, if you just know it, you can just go ahead with it. Otherwise it will be very difficult for me to explain the theory also. There is a time constraint. Okay, so I cannot in one video show you the theory, solve this problem and then go to this problem. Okay, so I will just tell you the little bit intuition. Okay, you see if you can understand. So what you were doing so far is that you are calculating the towers of ones. Okay, you are calculating the towers of ones, and from the left you are storing min so far, minimum so far, but you are using a loop for that. So get rid of that loop, you can use a stack. You keep pushing element into your stack as you are iterating through the heights array. You keep pushing elements into your stack. Okay, and whenever you get something which is decreasing, you keep iterating in your stack. You just keep popping elements in your stack and reduce them. Okay, so you chop this value. Let's say this is 3 and this is 2. You see that stack.top is now 3. Okay, so whenever if that is 3, you just chop it to 2. Okay, you just chop it to 2 to your current element. Okay, in this way you just ensure that whatever things you are adding into your answer, that remains a monotonically increasing function, and this stack, and it is known as a monotonic stack. I will definitely not expect you to understand everything, okay, here, but I will definitely write this solution. So if you can understand this, it's very good. So let's see. You just calculate this height, whole of this height array at once. Okay, and what you do next is simple one, I guess. It's not that difficult. So you see, what can be written now is that you can have a vector sum. You can have a vector sum. Okay, so it can go till n. Okay, so you can store the sums. You definitely need a stack. Okay, I will first definitely suggest you to understand the theory of monotonic stack first, okay, and solve this problem, and then only this problem will be very clear to you. Okay, now what you do is that while stack is not empty, okay, so what you do something like while stack is not empty, and you just go to your height, and you just keep you have already pre-computed of your height for this particular row, right? So you go to this height and just tell that if stack dot top is greater than this current value. Okay, it's greater than this height of j. Okay, so stack dot top is greater than this height of j. So what does this j represent? I will write another loop which will take for j goes from j to n. Okay, so for this loop only I calculated this, I pre-computed this height, but again I need to iterate it. Okay, so I am doing this iteration again. So you see the complexity is still n square, it has not increases, and even in this while loop it does not increases. If you see, uh, you are just copying the useless elements. You are not I mean, you are necessarily not every time going back. Okay, you are not every time going back. That is the beauty of monotonic stack. So every time you do not need to go back, only for some particular times. Once you have, I mean, you need a strictly decreasing function, right? So once you have chopped off one value, you do not need to chop it off again. So that is the thing. So while stack is not empty, what you can do is you can have this p and this stack dot top. Okay, uh, as you get this p, what you can do, you can store this into your sum array. Now sum will store all of my values. This sum of p is nothing but this h of j into j minus p. Okay, why I am doing j minus p? Because so it's like you have something. Okay, so uh, you have in this way, and let's say you consider your current border to be rightmost border. Okay, so this comes in monotonic stack. Still I am just telling you, you just consider the particular border as your rightmost border, and you try to find the next element which is just less than you, and you consider that as your leftmost border. Then the rightmost border is j and the leftmost is p. Then you can just tell that j minus p into this height. Okay, into this height. So that you can just add it to your answer. Okay, and what you can do, you can have an else also. So if you have doubts regarding the monotonic stack algorithm, you just search in YouTube particular video. Okay, you will get that, and then you can understand this problem really easily. Okay, so yeah, I have it, and for every iteration I will just push elements into the stack. Okay, and definitely my answer will be, as I had done previously, my answer will be nothing but this sum of j. Answer every time I will add this j into my answer, and I hope this would. So you see, I had initialized this h wrongly. This is not h, but this is height. Okay, so I am having this height array. I am not storing any h variable right now. So if I run this, you will see an accepted thing, and if you try to submit it, it will also get accepted. The memory is not so good, but definitely the runtime is great. So yeah, that's all. I guess that's all for this problem. Uh, I mean, it was not possible for me to explain you the monotonic stack and then again explain you this largest histogram problem, which is in fact a sub problem of this one, and then again explain you this in complete detail. But I have tried my best to do it in the shortest possible way. Okay, I tried to keep the video short and as well as give you the code and at least give you the intuition. Even if you have not understand this one, I hope you did understand my previous solution, which is also very similar. It does uses a different data structure, and that does not uses, but the intuition remains exactly the same. So I hope you do get it. Okay, I hope you have got the intuition. If you have got the intuition, then definitely like this video and subscribe to my channel. I will keep putting some great videos on basic concepts of DSA also, so that these problems will never be a problem for you. Okay, so never be difficult to you, or it's not that. Okay, so in the editorial also you can see, okay, there are two approaches, and you can just see, okay, you can just go through it. They have done the stack only, they have done a little bit a different fashion. So you can just go ahead and check these approaches. Okay, so yeah, that's all for this video, and I will meet you in the next video. Thank you so much.